beam deflection formula. Actually, sa mga textbook, makita ninyo siya, no? Sa topic na beam deflection. So, the formula here is already made, and it's just a careful understanding on how to use it. Okay, so, kumbaga, kung isda pa ni siya, pispili na ni siya, wala na ni siya ikuan, wala na ni siya mga kuan. So, dito na ni siya, no? Gamiton. So, atong what we have done last week is a different approach because you have to understand the system and then make your own equation and then use it, no, for finding deflection. In this case, the first part of establishing the equation is already omitted because the equation is already here. So in the table there are one, two, three, four, say five cases, no. But there are also books that present a lot of cases, but I'll say that this is just the basic cases. So if you know how to use it, you can use also for other load cases. Okay. So the first case is we have simple beam of length L. So it is intentionally in variable form so that you can have it as a function of x. So usually the length is labeled as L, but it will depend on how long the beam you are actually soldering. We'll have an example later after this. So the load is uniformly concentrated load applied at the center. And presented here is already a deflected shape, no? A deflected shape of the beam. Supposedly this is straight, but there is a load P, so this is how the beam deflects. So that it will aid your imagination or why the beam deflects. But however, this will go back to its horizontal form if the load is removed. No, removed. Now, in this case, you have also a deflection, but the deflection is not symmetrical compared to the first one. You will ask why? Because the load is not also symmetrical. The load P is off center, no? It's somewhat biased to the right. So the deflection also looks like this. Okay. Again, if you remove the load, it will return to its horizontal shape. So the deflection there is just assumed deflection, but this is already correct now. Okay, so you will see also that at the boundary conditions, I mean at the support left and the right, there is zero deflection. Unless the problem will specify that the support settles, let us say settles 200 mm to the right due to the load it is carrying, and perhaps it settled because the foundation is constructed on a soft soil. So that could be foundation failure, no? But here we don't discuss foundation failure, no? Although a topic like that is also a topic in structural engineering, or what will be the result of your analysis if that case will happen. But in this discussion, that that settlement case is not discussed, no, unless it's really our topic. Okay, number three, you have a uniformly distributed load from zero to from the left support to the right support. Meaning the uniformly distributed load is fully applied. No, there is no gap wherein there is no load. The other one is when you have moment applied at the other end. Okay, this is the resulting deflection. On the other end, you just reverse that. This one is uniformly varying load. No? So its deflection is again not symmetrical because the load is triangular. Okay. So columns here, you have slope at the end. So subscript 1 and 2 refers to the first and the second support. There are two supports in the beam in the first column. So the first one is support 1, and the second one at the right is what we call support 2. That explains the subscripting of 1 and 2. Okay. So you have this, no, like this. but signs are not, the signs are not specified. I think it will just follow with the sign of the load. Here you use P negative because it's downward. Okay, so it's like that. Okay, so for uniformly distributed load, it has also a different value, like that. So I will have an example. No? I will have an example. So that we know how to use it. No? Okay, so uh, okay, class. I have just shown you the table, the table for this. Okay, so okay, so that is the table class. That we are going to use this morning for problem solving. Okay, so the second part is I will go through some problem solving. Okay, so that's just a table that we are going to use. So I just show you so that you know what's the form of it. But it's not really new because in your mechanics of deformable bodies, you are discussing deflection. Okay? But since deflection is very important in theory of structure, so we must discuss how to find accurately the deflection. Okay, so the second part is I will have a problem solving. Okay, so it will look like this. I will present the window. Okay, and then I uh, sorry, not there. So I will present. Uh, so uh, this is our topic for this morning. Uh, it says here beam detection using beam detection formula. That means that we are going to use the table. Okay. So since I have mentioned problem solving, so I will rewrite a problem. So I will say problem. Okay, and we will solve it. No? Because okay, so problem is something like that. A beam, a simple beam. Let's start with a simple beam. So by writing simple beam, you're already imagining a beam, no? It's just roller support on the other side and pin on the other side. Simple beam, 10-meter long, or simply I will just say a 10-meter long. Mas simple siya. 10-meter long, simple beam. Uh, a simple beam. We'll just put a description, prismatic. If I see prismatic, meaning it has constant cross-section all throughout. No? So if it has constant cross-section all throughout, its moment of inertia, no, is constant. So its I is constant. Now, if you are using only one material, like for example wooden material, so its EI is constant. Okay, but if the beam is made up of two materials, let us say you join the wood and the bamboo. I do not know how it is being done. So the value of your modulus of elasticity changes as the material changes. So in that case, you have two types of material, so EI is not constant. But let us say that EI is constant. Okay, so 10-meter long prismatic simple beam is carrying uh, 100 something like 80 kilonewton concentrated load. Concentrated load at. So because 80 concentrated load is still not very clear where it is being applied. So you just place the term at. We'll say uh, 6 meters from lip support. lip support. Okay. We just put a statement that assume EI is constant. This term EI is what we call uh, beam stiffness. No? This is the stiffness beam. Stiffness, so kung kabalo mo, unsa may, what is the Visayan term for stiffness? Stiff. Stiff. What's the Visayan term for stiff? Anybody? What is the opposite of the term stiff?
Still, sir?
Stiff is Tiff. Stiff. What's the opposite for the term stiff?
Humok, sir.
Yeah, English it's
So,
flexible, no? Flexible. Humok, flexible. Okay, that's correct, humok. Or huyang. Huyang is the proper term. When you say huyang, humok siya at the same time, dili sa bigon ang iyang material, di ba? So, duha man na permanente that makes up the stiffness. It's the kind of material, kung kahit ba nga material o humok mga material, ikaduha is ang iyang ginakon. Okay? So, mo na siya. That's why it's called EI. E for the type of material, elasticity of the material, and I is the size of the material because I refers to beam dimension. Okay. Assume EI is constant. Okay. Now the problem is determine the following. Okay, following lang where the problem following. Okay. The A, the deflection, the vertical deflection, vertical deflection. Subong sa natin yung upan. Okay. The vertical deflection at x equals to 4 meters. Okay. B, the slope at x equals to 5 meters. Okay, the maximum deflection. Maximum deflection. Vertical deflection. Vertical deflection. So, let us see tulog ka book yan, ano problem. So, kung atong doing mo ng problem, this one, no? So, figure. Okay, figure. So, mag-drawing sa figure. Okay, shape. Okay, so you have a beam. Ato lang na siya padakon. Dipon ko na siya. Puluran na ito dito. Dipon niya na si 2. Okay, 1. Then, ato ba support, no? Support. Okay, ato na lang. Araw na lang itong support para di kahit magpanuguras, no? So, ato yan pong nag-code siya. So, ang color niya is itong nagyapon. Kopyahon ka na siya isa. At na siya muna siya ang lip support kunuhay, no? Lip support. Then, second is, we'll copy that and paste again. Put that here. The load is located, we have unloaded 6 meters from lip support. So, you have a load here. Okay, ito na siya po. Okay, load na diya. Pero, ini siya, ato sa siya i-join. I-join sa siya. I-group siya natin siya. Okay. Okay, so ang load actually is, ilabit ang load na to, 80 PM. Yeah, let us say, paano siya, the support. No? And then this one is 6 meter from lip support. And the other one is 4 meters na lang. Why? Because L is equal to 10. Okay, that's the load. Then if you are going to imagine what is the shape of the deflected structure, then we can make a load here, no? Okay, yung line, may mga natin manana. Yung color niya, red lang para contrast. Okay. Okay. So, that is what it is. No? So, if you are going to use the formula, actually, the formula is, I will just paste the case here, no? The case. So, I will have this. We have case number 2. So, I will only show the case. So, may tabudan na. Morning ang formula atin dito. Morning ang formula. Ini lang, no? Di na ka magkuhan. Magkapaglain. So, if I am going to use a formula, I will use this. I will paste that. Okay, so, I can use this, no? So, I can use, if A, actually, if A is lesser than X equals to L, actually, the X that we are using is at X equals to 4 and 5. Now, the A here is the distance from lip support to, I will just refer this figure, no? This one. The A is equal to 6, no? A is equal to 6. So, here, A is equal to 6. So, dapat sumulita niya siya. And then, the L is equal to 10. Then, that will be our quantity. The X depends on what you are going to use to determine 4 ba, letter A ba, letter B ba. So, that's it. No? So, for both letter A and letter B, X is equals to 4 and 5. And L is equals to 6. So, if you are going to use these two formula, you use only one. No? So, if X is lesser than A ba, or A ba is lesser than X. So, I think the first formula, 0 is equals to 4 meters is lesser than 6 is okay. So, use this the first formula. Actually, there are two formula here, no, but the question is which one you will use. So, there's a condition here. If 0 is lesser than X, equals lesser than A, and the other one is for A lesser than X, is lesser than L. Now, for part A, use that one, the first one. Use the first one. So we will use that one. I will basically cut that out here and go back. So put that here. So use that formula. No? Use that formula. Okay. So here you can determine if L is equals to 10. If L is equals to 10. Okay. So you can say that Y is equal to Y at 4. Y. I just put it as a subscript. No? So y at 4 meters, y at 4 meters, sana 2 meters. Para, muna i-attribute ang subscript sa iya para pan. So y at 4 meters is equals to uh, PBX. I will just put this on a one on a I have here P which is going down. P is going down. Okay, that's negative 80. I don't know if it's positive down, but let us just determine what's the outcome, no? And then times B. B here is equal to 4 because A is 6, so B is 4, and then X is also 4. Okay? Okay. At X, now we will just put here at X equals to 4 meters. Y is equals to Y 4 meters. Okay, ano na to sa pagbutan. Okay, so that when you do that, so PBX is like that. Then you have also 6, and I think that's L, that's divided by 10, divided by EI. Okay, that is what is inside the parentheses. Okay, then you have the inside the parentheses here, L is equals to 10, so L squared is 100 minus X, which is 4, squared of that is 16, then minus B, which is 4, also minus 16, so that's it. So here you can have Y4. Okay, so I will multiply. So 800 minus 100 minus 32. 100 minus 32 is 68. Times 16 again. Times 80. You have 87,040. Then divided by 6. Divided by 10. So you have it now. You have 1450.6. Put negative. Negative 1460. 0.66. Now you will wonder, kada ko gusto guys the depiction at 4 meters. It's because you do not input what's the value of EI. EI is a very big number. Remember, E is you have a 1,000 divided by a big number, so that it will come out that the depiction is just very small. It's very small. Here it appears big because EI is not yet para to ma-substitute value sa EI. So this is it, no? So I'll review again. 80 times 16 divided by 60 times 100 minus 32. You have 1,450.667. That's negative because why 80 is negative? So 80 is downward. No? If your Y is going up and then the load is downward, so you are using the global coordinate system, so your load should be negative. Okay. Now, this equation does not mean only that you can determine depiction at x equals to 4 meter, no? Actually, the formula here is a function of x, so you can use any value of x, no? But in the end of the equation, there is condition. So the understanding of this condition is will let you know which formula of this is you are going to use, no? Okay. So that's for answer number for the 3, no? Maybe I'll make a table here, no? Table. I will insert a table. Table na lang ta, no, anak. So the first table, this is part A. The second is part B. Part B and then part C. So I will move this. Then maybe I'll copy all of this. I put it here. Okay, so that's it, no? So I will just already. Okay, so that's half, no? That's parking. Now, if you want to determine the slope at 5 meters, so here, the slope here is not a function of x. It only says the slope about the lip support and the y support. So we are not going to use that. So in part B, we are going to use the same formula actually, but at y equals to 5. No? So I will use this formula, home, copy. You have to be creative also. But, not formula is all given, but we know that dy dx, dy over dx, the derivative of y with respect to x is equal to theta. No? Theta. Theta. So I will delete this small letter d. This one will be theta. Okay? And all you have to do is just derive this. No? You have to multiply this. So the first term is I will put the x inside. No? So PB and 6 over L over EI is put outside. Okay, put outside. So x is put inside. So here you will have L squared x minus, I will make this capital. And the other one is minus x cubed minus b squared x. So manang formula. So ato sa siya himuon na subscript, superscript. Okay, superscript siya. Superscript. Okay. So if we are going to determine for theta, the theta. So kini siya ang derivative niya aning L squared x will become L squared. Okay. So butang natin siya ddx dere, ddx derivative of that, no? ddx d over dx. Okay. So derivative of kining x mawala na siya. Kaya kini siya mahimo siyang 3x squared. And also this one mawala ang x. I-derive mo. Okay? I-derive mo. So kung na lang itabo. So that the theta that we'll be having is dunakay minus 80. Ang b is equals to 4. 4 na siya. Ang 6 lang yapon. Ang L mahimo na siya na 10. EI lang yapon. Kini siya mahimo siya 100. 100. Ang 3 times, actually at x equals to 5 na siya. X equals to 5. X equals to 5, so 3 times 25. 3 times 25 is practically 75. Then b is still 16 because b is 4 and square root of 4 is 16. So that's it. So we can have theta here. We just copy this. Theta, which is 80 times 4. Ano sa atin yung suit sa part, this is 100 minus 75 minus 16. That's 9 times 80 times 4 divided by 6 divided by 10. So that negative 48 over I. So muna siya theta at x equals to 5. So almost 0, no? So that's it. So you will have 100 minus 75 minus 16 is 9 times Pt negative is 720 times 4, then divided by 60, you have 48. So that's the slope here. That's the slope of x of b. Okay, then we will go with maximum vertical deflection. So uh, we can use either of this equation and set that to 0. So for part C, uh, maximum, all you have to do is to understand, no? What are the conditions when maximum deflection exists? Maximum deflection is when theta is equals to 0. Okay, when theta is equals to 0. So if you are going to find the point where the horizontal slope, no, the horizontal line here is horizontal. So that point, particular point, is the point where the maximum deflection occurs. At other point, the slope of the tangent line is not zero. So it only happens when theta is equal to 0. So all you have to do is to use this equation. Okay, we have this equation already in terms of x, but you have to set that equal to 0. Okay, so what happened is that the first parenthesis vanish, so you will have something like this one. You will have only this equation. You have only that equation. Okay, what happened to the first equation? Well, it vanished, no? So that equation. Then if you substitute, this is 100 minus 3x squared minus 16 is equal to 0. Then you can have 3x squared. 3x squared is equal to 100 minus 16. 84. Okay. So your x is equal to 84 minus 3 divided by 3, then square root. That's 5.29. 5.291502622. Okay, that is the point, meters, where the maximum deflection occurs. So somewhere here, right here. So nana siya din dapit. 5 to 10. Ada na ko maximum moment. Okay, na dia ang maximum moment. In second temponan. 5 to 10. 29. Okay. But this one is not the deflection. Okay, part C is looking for the maximum deflection. So this one is only identifying where the maximum deflection occurs. So that means we are going to go back into this equation. Okay, so go back to that equation. So the space for addition, so not one. But the value of x should be 5.29. And so x equals to 5.291502622 meters. Tama. Maximum deflection theta y is equals to y max. Okay, y max. Okay, y max. So in that case, we are not going to use this equation there. That equation, cut na siya. So we are going to use the equation of y. Okay, this one. Okay, we are going to use that one. Okay. So y max is equal to the same amount here, the same amount here, copy, times the quantity inside. The quantity inside you have L squared, which is 100, minus Canada yun siya. No? That is 84 divided by 3. That is the value of x squared. Okay? X squared here is 84 divided by 3. Then minus then 16. Okay. So, y max ay, subscript. Okay. Y max is, copy, y max is equals to 100 minus 16 minus 84 divided by 3 is you have minus 3. 184 divided by 3 is 28. 84 divided by 3 is 81 minus 16. That's 6. 81 plus 16 is 97. So 3 na lang. So you have 80 times 3 times 16 divided by 60. Yun na kay minus 64 over ay, ano mas ako kung gusto? One hundred and 16 minus 16, 68. Here, x squared minus 84 divided by 3. 84 divided by 3. 84 divided 84 divided by 3 is 28 plus 16. 44 to 100 minus 44 is 56 times 80. 56 times 80 times 16 divided by 60. So 1450 3x squared. X squared is 84 divided by 3. 100 minus 16 is 84 divided by 3. 28 plus 16 is 44.
Dili sub ang ano sir, X.
Ha?
Kanang 5.29.
Ay, oo, din hinapit, no? Kini siya mo na siya.
Ah,
Right you are. 5, okay, X man. 5 point. Sakto na siya. So, 5026. Correcta. No? So, 100 minus 84 divided by 3 minus 16 is 56 times 80 divided 80 times 4 times 5.29 150 2622 is equal to that divided by 60 1580 negative 1580. Now if you compare the first one, mas dako na siya one magnitude. Negative lang siya because negative means it's going down. So, over EI. So, that's the maximum, no? Okay. So, that means that we can use one of this equation. Just understand what is the condition at the end. Okay, because uh, it depends on the location of your concentrated load. Okay, so you can use it. Now you can all okay. So part A, this is the deflection 1450. Then the maximum the theta at 5, maybe at 5, so maybe I will put a subscript here 5. Theta is also 5 and also theta is 5. So okay. Okay, so mo na yung iyang kuan, deflection. So that's how we analyze it. Okay. So for your if for example you have uh okay, so I will save this, no. So ay mali. Ito ang pawis natin. So for example, you have multiple load, like you have a concentrated load and uniformly distributed load, and then you see it's not found in the table, no, but in the table you have a concentrated load and you have a what we call uniformly distributed load. So you will just use the principle of superposition. So imo siyang i-superimpose ang duha ka case. So, imo siyang i-break down into basic load, and then work on the basic load. So that's how it is. So breaking down them into its simple form. You have a complex form. You just break them out, break them into simple form. Okay. So you can still use the table. So an example, I don't know if you can finish it. No? So second example, I will present again. Okay, I'll present again. The second example. Let's say that's like this, no? Like this. Example two. Example two. Okay, example two. Okay. Determine the deflection just like of 12-meter long simple beam loaded. Determine the deflection at x equals to say 5 meter of a 10 meter of a 10 meter 10 meter long simple beam loaded as shown. Loaded as shown. Just say EI is constant. Is constant. Okay. Constant. So here we are going to make a figure. A figure is easy to imagine from the narrative problem. Okay, because you have a simple beam here, then maybe we can use this. We can borrow this. Okay, I'll copy that. Copy and then post it here. I have to do paste here. Okay, yes. Nah, kabuk. Okay, on that. And then maybe I will ungroup this and group. Okay. I will add another load here, which is this one. Okay, I'll just put that in the middle so that will become simple. And then this one is saan ba natin siya pagkuha na shade? Fill. Pattern na itong fill niya. Sige, ang pattern niya. Okay, bisa na black natin ko. Ay, pattern 2. Okay. Ano siya, no? Then, ako din siya i-group. Okay. Ano siya? Group. Okay. That's 1. So, first, load niya. Tata 50 ni siya. 50 PN. Okay. Now, this one is 10 PN. PN per meter. I'll push this down. Okay. I'll push this down. Okay. And then the length here is you have 5 meter. No, 6 meter. 6 meter. 6 meter. So here, 5 meter is still here. No? So I'm going to make deflection. Deflection. Ano ito make mo? Dako na ako pa. Yan, line niya. May isang ito na. Color. Mana. Okay. So basically, you are going to determine the deflection at 5 equals to 5, x equals to 5 here. Okay. So that is the point where you are going to determine the deflection. It's not really the maximum deflection, but close to it, no? Because here you can guess the maximum deflection is in the middle because the load is symmetrical. There is only one reason why the beam is not symmetrical if the cross section of the beam vary. No? Like for example, dako yang cross section din kita din so dili gyud nga ni ang deflection. Okay. So we are going to use this formula. Okay. We can use the formula, copy here. Okay. For case number 1, you are going to break this into like this. No? Breaking down. No? I will make a table. No? So solution, break the loadings. Okay, there are two types of loadings into basic loading. Okay. So I will make two cases here, no? So I will insert a table. Okay, then two. Okay, this one is for case number 1, and this one is case number 2. Now, the case number 1 is this one. This case number 1. Okay, case number 1. That's case number 1. Okay, and its formula is you can use this one. You can use that one. But you know that it's not only concentrated load that is acting on your problem. There is also a uniformly distributed load. But if you see it in the table, there is no such thing as combined concentrated load and uniformly distributed load. That's why I see here that break the loadings into two basic loadings. Number 1. For case number 2, it will be like this. Case loading. That is case number 2. And the formula that you are going to use is equal to this. Okay? So, nakita niyo class, ang duha ka case, ang isa ka case, gi-break na ko into 2 cases. And the reason is that there is no formula for this case, but there is formula for this. But if you are going to add this case, So it will be equal to this. So that's the reason you can make this answer. Just like, for example, na kay mga, grabe kayo ng mga compound, pwede na nimo i-break into basic element, no? Kaunin mo ang hydrogen, kaunin mo oxygen, na. So, para makuha nimo siya. Masabtan nimo pag-ayo kung pilagi ko siya. The same here, imo siyang break down into its simple form. Okay? So, you have a simple form, you have a simple loading, concentrated load, and that this is the formula. So, meaning that at x equals to, I think we are looking for at equals to 5 meters, 5 meters, y becomes y 5 meters. Okay, that will become. So you can determine y equals to 5, y 5 meters is equal to p is pinatong p na to minus 50. Okay, minus 50 times b. Ang B niya is 6 meters gyapon kay naman sa tunga. Ang A ug B equal man, so ang B is 6. Then ang X equals to 5 over dayon ang 6 divided by 12 again, and then the EI. So mo na siya una. Nasa sunod is you will have 1 for 4. Asa mo nagikan ng 1 for 4, gikan na siya sa 12 times 12 because your L is equals to 12. Now, the formula C is square, so that's why it becomes 1 for 4. And then the x squared, x equals to 5, so that's minus 25. Then minus, the value for b squared is 36. Okay, so your value here, this will become a side squared. Okay, will be equal to this. Okay, over EI, kung ano na siya. And I'm sure that's negative, you know, that's negative. Negative because 144 minus 25 minus 36 is 83 times negative 50 times 6 times 5. You have that. You divide it by 6, divide it by 12. You have 17, negative 1729.1667 over EI. Again, you have 1 for 4 minus 25 minus 1 for 4 minus 25 minus 26 times 50 times 30 divided by 6 divided by 12. That's correct, no? Correct. But this one is not the answer because that's only the deflection at 5 meters due to the concentrated load 50. So you need to solve this one. So here you also say that at x equals to 5 meters, at x equals to 5 meters, y equals to y5. And then the formula, you use this formula, no? So W is negative, I think I use, that's downward. So I will use negative 10. Okay. Now I'm using negative 10 because the load is going down. Okay. Then you will have times 5, that's WX, then divided by 24 divided by EI. So that's the term. And inside the parentheses you will have L cube. That's L cube. So 12 xy3, that becomes 1728 minus 2 times 12. Okay, that's 2L times 25. Then you will have plus x cubed. 5 times 5 times 5 is 125. Okay. So you will have here y5 meters is equal to okay. So I will have pi here. Okay. So I will solve type the parentheses first. Okay. 2 times 12 times 25, then plus 125. Okay, minus plus 1728. You'll have 1003 times 50 divided by 1 divided by 2. So you'll have minus 2089.5833. Kapag ito yung sunod, late naman siya tayo. Hindi naman sunod. Okay, so to continue, but again, this one is not the answer, no? This is just the depiction due to this. So the answer actually is equal to the deflection at x equals to 5 meters is y 5 meters is equal to minus 1729.167 over EI plus minus 2089.588. So you'll have pinagawa ko split daan. Una ito sa i-check ni daan ko, ha? 1728 minus 24 times 25. Yan plus 125. Nasave ko sa kuan multiplication times 50 divided by 24. Kuan siya 216. No? Save ko. 216.416660. Again, you na to 2 times 12 by 25. Okay. Minus plus 1728 plus 1 plus 125 times 50 divided by 24. Okay, check plus 1729.166. So now, 433. 439.5. Okay. This one is changed to 216.416. So last, this is the answer, no? So I use new technique. We call it superposition. So you superimpose the two simple deflection, no? The two simple deflection. Okay. So I will make an assignment. Use problem 2. Use example 2. Use example 2. Okay. Determine the deflection at x equals to 8 meters. Okay. So it's easy because you are going to follow the solution for the example 2. So how we do this one? Okay, for example 1. Okay, so for example 2, no? So you're just going to use this, no? But the problem changes. You're going to determine the deflection at x equals to 8 meters. Okay, the vertical deflection. So mauna siya class ang inyong assignment. So at this point, class, do you have some comment or question?
Ay, sir, nakoy question, sir.
Okay.
Unsa nang denominator ana niya, sir? 6L times EA na, sir? Or kanang denominator bitaw sa Y, sir?
Sa asa nga case 1?
Case 1, sir. Case
6L
1.
over EI. 6L over EI.
Sige, sir. Sige, sir.
6L over EI. Ang isa, 24 EI lang.
Sir, ano siya may pass, sir, ang assignment.
Kini,
Mm.
karong Thursday, kini siya.
Okay,
Kini
sir.
siya. Okay.
Sir, question, sir.
Okay.
Sa example 1 man to, sir.
Oh, okay. We go to example 1.
Anong, gani, dy or dy over dx, naggamit ka na, sir?
Kining sa part B?
Opo, sir. Opo, sir.
Okay, because part B is determine the slope at 5 meters. Determining one slope. Slope is different from deflection. Because the slope means the slope of the tangent line at x equals to 5 meters. And we know the slope as the dy dx, meaning it's the dy over dx. That's the slope. And in the formula of theory of structure still follow the mathematical formula like calculus, because we are talking about deflection and slope, y and u. Dy dx is the slope.
Pero pwede ra sa tong sir, tong
Formula?
formula ana, sir.
Wala may function sa x gito, di ba yung function sa x. So, kini siya at support to gini siya. Wala siya formula sa slope. So, kung magbuhat ka imong table, butangan nimo ni siya formula, ikaw buhat yung table para magamit nimo ang theta at anytime. But at this point, since we don't have formula for theta, that's why we make our own equation for theta, because we know from calculus that if you have a function of y, the derivative of y with respect to x is known as theta, or the slope. And if you substitute the value of x for the slope equation, that will be the slope at x equals to 5, which means that it's negative 48 pi.
Okay, sir. Pero last na lang, sir. Kaning, kuan bitaw, sir, PBX over 6L times EI. Kuan na, sir, like as one na sila kanang sa denominator.
Oo. Isa na siya. Muna siya. Muna akong i-divide na lang. Divided by 6, divided by 10, divided by EI. Magunta equation na yung sinulatan. Pero kung ani gina siya. Multiply gina mo ng 6 times L over EI, mo na yung sa number. Before mo siya gamitin.
Okay, sir. Salamat, sir.
Ay, sir, na po ko last na ako ng question, sir.
Okay.
Ay, kanang part C, sir, ba?
Mm.
Gano'y na-vanish ang kanang isa ka formula, sir? Nabilin kay...
Okay, kung i-divide mo ang left hand of equation by that number, 1 man. 0 magyapon. 0 divided by 1, 0 divided by 2 is 0. If you transpose it to the other side, may mo na siyang 1. 0 over ang infinity katumang 1 over 0, kung 0 ang denominator, di ba? So kung ang denominator dito 0 gina siya. Kung baliktad siya, kung imo na siyang i-divide by ang right term, divide by PB6 L over EI. So kini nga value may mo 1. Ang kika side ay 0.
Sige, sir. Thank you, sir.
Okay. Kuhanin mo. Okay. So, yes.
Sir, kanang part C, solve for x, dito sa nawala.
Unsa ang?
Kanang
Part C?
Kanang pag-vanish bitaw, sir. Solve for x. Or...
ang 100 minus 16, na mo na siyang 84. So, may mo siyang negative 3x squared equals minus 84.
Okay, sir. Salamat, sir.
Okay. So, ang x squared, 84 divided by 3. Or x equals 2.529. Okay, so I have a class. So,